Today, let's talk about telomeres. So what is a telomere? Telomeres protect the integrity of information-carrying portions of DNA by serving as caps on the terminal portions of chromosomes. They prevent base pair loss of chromosomal DNA. These telomeres prevent the deterioration of chromosomes. Over time, as cells continue to divide as you age, the telomeres shorten but can be replenished by the enzyme telomerase. Today's scientific paper examines telomere length shortening. The paper was titled Physical Activity and Telomere Length, Impact of Aging and Potential Mechanisms of Action. The study was done to examine the relationship between physical activity, exercise, and telomere length. It was done on a wide range of individuals, including both males and females, finding that higher physical activity has a positive relationship with longer telomere lengths versus a sedentary individual. Physical activity shows potential in improving well-being and increasing longevity. In the study, they did a small number of exercise interventions to examine the potential influence of chronic exercise on telomere length, but these studies have not fully established such relationship. Findings included changes in telomerase activity, oxidative stress changes, and decreased skeletal muscle satellite cell content. The goal of the study was to examine the potential influence of exercise on telomere length, but the results did not establish a definitive causation, only correlation. What's the primary cause of telomere shortening? Aging. The characteristics and symptoms of decreased telomere length include aging, cancers, chronic disease, and people who live sedentary lifestyles. It can be used as a biological marker for aging, and telomere length is strongly associated with healthy lifestyle. Risk factors include several age-related diseases, including cancer, cardiovascular disease, obesity, diabetes, chronic pain, and stress. Also, the shortening of telomere length can lead to cellular senescence, which is known as the end replication process. This can accelerate and increase the risk for many chronic diseases. The key takeaway from the article is that telomere length has an inverse association with chronic conditions and aging. Because telomere length shortening is so telling of other diseases, we can look to other disease prevalences to tell us about telomere shortening. As the author points out, telomere shortening results from physiological processes that are correlated to chronic disease and aging. The number of people suffering from chronic disease such as cardiovascular disease, diabetes, and cancer is expected to rise. In 2008, non-communicable diseases accounted for an estimated 86% of the burden of disease in high-income countries. By 2030, non-communicable diseases are projected to account for more than one-half of the disease burden in low-income countries and more than three-fourths in middle-income countries. Thus, it is an important finding for public health that physical activity could be used to resist the negative health outcomes expected for the future. Several potential mechanisms through which physical activity or exercise could affect telomere length are discussed, including changes in telomerase activity, oxidative stress, inflammation, and decreased skeletal muscle cell content. Stress is associated with the release of glucocorticoid hormones by the adrenal gland. Telomere length may indicate an individual's biological age, so stress would negatively affect health and longevity. The treatments and rehab include exercise, dietary changes, and an active lifestyle. Diets containing antioxidants and omega-3 fatty acid is associated with reduced rate of telomere shortening. Antioxidants can potentially protect telomere DNA from oxidative damage caused by extrinsic and intrinsic DNA damaging agents. The article provides quality empirical evidence for its hypothesis by analyzing and presenting the results of numerous studies. The authors provided a groundwork for the study by providing information about research already being done on the topic and using adequate citations to back up their claims. The results are likely to be generalized due to the broad study population. However, it is not known if the authors had confirmation bias or conflicts of interest. Summary for mom. A telomere is the DNA segment found on both ends of the chromosome. They can be compared to the plastic ends on shoelaces that keep them together. Each time a cell divides, the telomere gets shorter. They can make a good biological clock. Their shortening has been linked with aging and chronic diseases. Exercise, diet, and controlled stress are all important for telomere health. Keep your telomeres, live stress-free, and exercise. You will live longer.